Welcome, viewers, to another episode of the It Depends podcast. This one covers all the major announcements from Snowflake Summit 2025, which took place from June 2nd to the 5th in San Francisco's Moscone Center. What you see here is a classification of some of the more common or more well-known announcements. There's a long tail of announcements. This categorization is how I have put these new announcements in order to share with you, not necessarily how Snowflake may go to market with. Second thing I want to also point out is that some of these announcements are very new. They may not be generally available. They may be in either private preview or public preview. Please check the latest Snowflake documentation to see the current state of these announcements. With that, let's get started with the first area, and we will look at the platform. In this, I have listed three different announcements, the first one being adaptive computing. So, what is that? Anyone who has worked with Snowflake knows that from day one, Snowflake was a cloud native database where storage and compute was separated right from get-go. You could have one shared set of storage with all your tables, but you could bring any number of compute clusters and take them down when the job was done. There could be a compute cluster for ETL, another one for reporting, another one for data quality, another one for some machine learning tasks. And you actually paid only for compute separately. You didn't have to scale up both bundled together. Now, that was amazing. But this compute cluster, which Snowflake calls a virtual warehouse, you had to pick the right t-shirt size. That t-shirt size varied from extra small to 6XL, and each t-shirt size had a certain number of resources. If you ran out of resources, then you had to pick a different t-shirt size. Now you have to see a common theme on across all of these announcements that we will look at today. And Snowflake's entire creation was simplicity. That's why people fell in love with Snowflake, and that's why Snowflake continues to be such an important data warehouse. In fact, going into this summit, Snowflake has seems to have gotten its mojo back. It had a gangbuster quarter, the first quarter of fiscal year 2026, reported excellent growth numbers and a run rate which will exceed $4 billion in this fiscal year. But creating these virtual warehouses and having to choose the right t-shirt size is not simple. You have to know what the right size to pick, and if you don't pick the right size, you may under provision your compute cluster, or most likely you will over provision it and you will waste money. So now with adaptive computing, Snowflake has introduced a new command. It's called create adaptive warehouse. And if you do that, then Snowflake will automatically pick the right sized compute cluster for you. And in fact, it picks from a cluster of shared cluster, and it has an intelligent router that does this automatically elastic scaling depending upon your workload needs. So that's the first major change in the architecture of Snowflake. By default, it is still a virtual warehouse, but you can now pick adaptive computing. The second thing that you see here, and also related to that, is the third performance improvement, is a Gen 2 warehouse. This is very interesting because Snowflake has combined several hardware and software optimizations into what they're calling Gen 2. Today, if you go to SQL or you go to Snowsight user interface, you have a drop down and you have three choices: standard warehouse Gen 1, standard warehouse Gen 2, and Snowpark optimized warehouse. What is Gen 2? It is a set of collection, like I said, that improves performance. performance enhancement could be anywhere from 2x to 4x. And that performance enhancement encompasses pretty much the entire gamut of Snowflake, from Spark jobs to Snowflake tables to Iceberg tables, whether they are managed by Snowflake or they are externally managed. The cost of this new environment is 1.35x. So it costs 35% more per credit. But if you factor in that you get 2 to 4x performance improvement, then overall your cost should come down. Let's look at the next category, which has only one bullet, and that's CrunchyDB. What is CrunchyDB? Crunchy database is a open source Postgres, and it has been around for a very long time. So it's well known because Crunchy data has such deep Postgres roots that they actually contribute quite a bit to the community. For example, their Kubernetes operator has been contributed back into the community. Crunchy data is also known for being extremely well hardened. DoD, Department of Defense, standard hardening of this Postgres database. The question that begs is, why did Snowflake have to acquire a Postgres database? Because after all, it's in the analytical space. One of the reasons is because all the database companies today are competing with hyperscalers. Hyperscalers have the entire gamut of, of services. So that is why you see there's been a massive recent spate of M&As going on in the data and analytics space. This is an example where Snowflake owns the analytical space along with a few other vendors. Some of them we will talk about in this podcast. But now it also wants to play where the data is created. Data is normally created in transactional systems, operational systems. So Snowflake tried to get into that. It did introduce 2 years ago this concept called Unistore that gave it the transaction capabilities. But Unistore has not been as widely accepted as Snowflake had expected. One of the reasons is because it's very difficult to take a data model that has been optimized for analytical use cases and make it optimized for operational needs as well. So by getting a Postgres database that serves the need. There's a second reason why uh, why the need to acquire a transactional database, and that is because we are rapidly moving into an era that is agentic in nature. The current spate of monolithic applications, whether they're ERP or CRM, can most likely get disaggregated into several agents. For example, if it's financials ERP with a number of modules and it's a massive piece of software with very complex business logic, it is quite possible that we may have an agent for accounts payable, another one for accounts receivable, general ledger, fixed assets, and a whole slew of these agents that talk to each other. And they, of course, have to talk to external tools. They may talk to a browser to get user requests. They may talk to a database to get some customer information. Those protocols for tools are now getting standardized on Model Context Protocol from Anthropic or MCP. Agents to agents also communicate with several different protocols, the most common one being Google's agent to agent or A2A, which is now accepted by over 50 different vendors, or mostly all of them accepted. MCP is stateless. So where do you store state? When you go from, say, accounts receivable to general ledger and you need to update, send information, you need information about the user. And so you need access to a database very quickly. it is expected that these agents may have their own local data to store context, state, and any other preferences, customizations, any of this information. Are customers asking for a local database connected to an agent? Absolutely not, because this is still very early days of this. But forward thinking, we think that this would be a need. And that's why you see not only Snowflake acquiring Crunchy DB, but also Databricks acquired Neon DB. Very different databases. Neon is a totally serverless, disaggregated store and compute, very lightweight. It comes up and goes down in seconds. And in fact, a lot of Neon databases are being created by agents today. So Databricks paid $1 billion to acquire Neon. Snowflake paid $250 million. But with CrunchyDB, they get the state-of-the-art security, Kubernetes, and very deep enterprise support. So with that, let's move on to the next space, which is data engineering. You see several announcements in this space. Very, very interesting to see what is happening in our ecosystem. Snowflake has a very strong and a thriving ecosystem, but Snowflake itself is becoming the ecosystem. And why I say that is, let's look at what is OpenFlow. In November of 2024, Snowflake acquired a company called Datavolo. It was created by two people who had left Cloudera. One of them, Joe Witt, many years ago had created a data movement standard called Apache NiFi. At that time, he was in highly secure US government, NSA, where he created this technology to very efficiently move data. In fact, interesting fact, he started with unstructured data, and then he moved into structured data. So Snowflake has taken this acquisition of Datavolo, and it has created a new service, which is called OpenFlow. It is data movement, ELT to some extent, and it's now competing with other ELT vendors like Fivetran, Stream, Informatica, Matillion, Oracle, ETL, Talent's ETL. So there are a number of tools, and this is where I was saying that this ecosystem, we are starting to see how this ecosystem is starting to shrink. If you look at the number of sponsors to Snowflake Summit, it is surprisingly getting a smaller number because a lot of these small companies are now getting absorbed. In fact, just last year, Databricks announced they bought a company called Acreon, and they announced Lakeflow. So Lakeflow, OpenFlow, very similar. Both these vendors, their attempt is to capture this $15 billion ETL or data movement market and bring some of that capability native into their own system. Now, one thing that I want to also mention, talking about Databricks, acquisitions, and Snowflake, with CrunchyDB, there was this notion or this perception that some people had, which is that Snowflake copied Databricks because Databricks literally just weeks before acquired Neon. But I just want to share that the reality is a bit different because the discussions to acquire CrunchyDB had been going on for quite some time, way before Databricks acquired Neon. So it was just a matter of timing, but both the companies were on the same path. In fact, Snowflake was actually also on the path to OEM Neon database before it got acquired by Databricks. So same thing. So I just want to clarify that it is not that Snowflake is reacting to what Databricks is doing, although it may appear to look like that. So now going back to OpenFlow. So what is the reason why why OpenFlow is such a big deal. Being natively integrated into Snowflake, it automatically is going to inherit the role-based access control features. So with OpenFlow, there are, by the way, over 200 connectors that already exist. You can now use NiFi inside a Snow site. So in the UI is now integrated, and you can create your data pipelines. Next, you can say, I want these data pipelines to be deployed. How you deploy it is very interesting. You can deploy it either in customer's own VPC, what is called BYOC, or bring your own compute, such as in AWS. That is generally available. Or you can deploy those pipelines as a Snowpark Container Service, SPCS. Those could be in AWS or in Azure, and those are in preview. What are the use cases that OpenFlow can address? Organizations now have literally hundreds of SaaS products, from marketing like HubSpot to Jira to all kinds of databases and all kinds of applications. So NiFi, like I said, has 200 plus connectors. It can take some of the connectors. For example, Fivetran has probably one of the more mature set of connectors, because a lot goes into building these connectors. You have to account for edge cases, you have to account for high concurrency, latency, reliability, high availability, disaster recovery, and and a very complex set of logic that can understand the data model of the source systems. That data model may change constantly. Also be able to apply rules, such as if you come across PII information, then mask it on its way to destination, and all kinds of rules. So Fivetran changed its licensing model from being volume-based to being based on connectors. Now, Fivetran CEO famously wrote a blog where he said 70% of Fivetran customers are actually going to see a decrease in their data movement cost. So it's quite possible that OpenFlow can come in and take some of the I would say at this point less complex, although the OpenFlow team would probably say that they are fully capable, but some of the less complex or long tail of integrations, they can offload from Fivetran. There are other vendors that can also do the same. And then over a period of time, Snowflake can then build their OpenFlow connectors with the deep functionality. Another interesting thing that was announced is the second bullet, which is SnowConvert AI. This is a new data migration, fully managed utility or service that allows customers to go from a set of traditional databases, Oracle, Teradata, Netezza. I was surprised to see Greenplum and some of these esoteric databases, also applications, also streaming, Power BI, Informatica, SSIS, and it can take data and code migrated into Snowflake. The reason it's called AI is because it is actually an agent that sits on Snowflake's Cortex AI. And interestingly, it is free in cost. So that is Snowflake's foray into trying to migrate its customers from some of these databases. Although I mentioned that one of the sources could be Oracle, Oracle is also a strong partner. If I go back to OpenFlow, for example, one of the OpenFlow connectors was announced at Snowflake Summit with partnership from Oracle. Oracle geeks would know that the write-ahead log is called redo log. Redo log has a number of APIs to extract the change data. So to do change data capture or CDC, you can use an older API called LogMiner or the new one called Extreme. So the partnership allows OpenFlow to use Extreme to take data from redo logs, which is transactional, and load it into Snowflake. Another thing that also happened going to the third bullet is there's a new architecture of Snowpipe Streaming. So although you can use OpenFlow with its NiFi backend to define the data movement pipeline, if you're writing it to Snowflake, then the second component that comes into picture is Snowpipe. Snowpipe Streaming is a new version, and the price of Snowpipe Streaming was reduced by 50%. Let's move on to a super interesting new announcement, which is called dbt projects. dbt is an extremely popular tool to do data transformation. dbt comes in many different flavors. There is the open source called dbt core. Then there is the commercial version from dbt labs called dbt cloud. A few weeks before this event, dbt rewrote the cloud or the enterprise ready version, and they called it dbt fusion. This one is written in Rust. It is a lot more performant, and it has a number of new features. So we will talk about some of these features even when we move further ahead in our discussion. So today you have to be in the dbt environment, whether it's core or it's fusion, to write your transformations using the Ginger templates. It's SQL, Python, and then you push it down to the engine like Snowflake for it to execute. What Snowflake is saying is that why have a separate environment for writing your transformations? We will give you a fully managed place for you to create, edit, monitor, and then deploy your pipelines, and that is this managed dbt projects. In fact, it's based on core. Although during the summit, Christian Kleinerman, head of products, announced that it also supports dbt fusion, but dbt fusion is very new. It's dbt core is primarily what it is built for. If you have already a set of workloads or templates in dbt core, you can export those and bring it into dbt projects. Now, when you do dbt projects, Snowflake has also created a new UI. It's called Workspaces. So Workspace is, think of it as a unified window, single pane of glass for you to see all your projects. And in fact, those projects can now be managed automatically by Snowflake. So Snowflake can help with doing versioning. It can help with some of the updates, CI/CD, and that is what's called data projects. It also is now using Terraform. Workspaces is also integrated with any of the Git repos, whether it's GitHub, GitLab, Bitbucket, Azure DevOps, AWS Code Commit, and it's bidirectional. So you can do your versions control in Workspace for your dbt projects, and you can push it to GitHub, or you can read it from GitHub. It also has now a copilot on top of it, so you can use natural language and look at it. So a lot of new enhancements are going on in this space. That takes us to the AI space, and the first one I want to talk to you is about semantic views. By now, you can see what Snowflake is trying to do is it is trying to collapse a lot of things that are in the ecosystem into Snowflake, so it can be managed end to end. For example, going back to data engineering, Snowflake has the whole observability and lineage. This lineage is based on OpenLineage. It also includes DBT, it includes Airflow. So you can see that Snowflake is trying to be the end-all, comprehensive, single pane of glass for all your data engineering tasks. So what is semantic views? When BI kicked off, early 1990s, with business objects, business objects had this concept of defining these semantics or these formulas. For example, what do you mean by gross profit, net profit, uh, all kinds of net retention, for instance, or net promoter score. So you could define these in business object universe, and they became hugely successful. When other BI tools followed, whether it was Tableau or Click or Looker, they all gave this ability to define semantics, so the business user could then do a query and ask for semantics, use semantics, and the BI tool would then convert that semantic into the right SQL and serve the results. DBT bought a company called SDF, and with that, they actually transform. SDF is what gave them Fusion. Transform is how they built semantic layer inside of DBT. What Snowflake has done is a step further. It has said when you create a table, you can define three things. You can say metrics, give a name, give the formula. Like, for example, gross profit equals total sales minus cost of goods sold. And then you can also actually give synonyms. So when a business searches for some other keyword, it then converts that keyword into the right metric and then executes that formula. Being right next to the data, they get this advantage of performance since it's all inside the Snowflake database. You can also define facts, you can define dimensions. So the reason I'm mentioning BI tools, by the way, BI tools like Sigma already support semantic views, but DBT, Fivetran, this is where we are starting to see that this ecosystem is starting to look a bit shaky because this cooperation is becoming more of a competition and less of a cooperation. Okay, but that's my philosophy. Let's stick to what was announced. You see, there are several new announcements even in the AI space. One of my favorites is called Cortex AISQL. Cortex AISQL is a set of SQL operators that perform generative AI functions. AI underscore extract. I write my SQL statement, I use AI extract, point it to a PDF, and I say extract from this PDF what are some entities, what is the sentiment. I can start asking questions. I can embed a prompt right into the SQL statement, use AI embed, use AI underscore AGG for aggregation, filtering. There is a whole slew of AI operators that have now been launched called AI SQL. Super exciting to see how the structured and unstructured analysis and manipulation is being rolled in to the most familiar SQL syntax. Behind the scenes, Snowflake uses an army of LLMs. For example, they use large language models from OpenAI, from Anthropic, Mistral, Meta, DeepSeek, and a number of other places. And then it executes these Gen AI activities, and it gives the results in SQL. The third thing you see here is Snowflake Intelligence. This is a UI that allows you to talk to data, use natural language and talk to data wherever that data may be, structured or unstructured. In fact, there's even a new feature that was introduced called deep research. So by using reasoning models behind the scenes, you can use Snowflake Intelligence and you can talk to your data and ask questions. Now, of course, if you talk to your data, you are going to be at the mercy of how the LLM interprets your request and does text to SQL. So to improve that, you have semantic views. So semantic views, Snowflake shared with us some of their benchmark numbers that show how much the accuracy improves when you use semantic views. Also, the last bullet here is Arctic models. Arctic is the name of Snowflake's family of models. They launched just before Snowflake Summit a text to SQL, which has more optimizations to improve the accuracy of SQL that is generated when you give it the text. In between, I mentioned agents and assistants. We've already talked about a number of agents. I mentioned SnowConvert AI is an agent, Cortex AISQL consists of agents. But the reason I mentioned this here is because Snowflake is also in the process of creating role-specific agents and assistants. For example, for data science, for its own help desk, we got a demo of agents that are being deployed inside of Snowflake. I have a trivia question for you. Do you know which is Snowflake's largest customer? The answer to that is Snowflake itself. Snowflake has 8,000 employees. They are all being moved to use these agents and assistants that are built on Cortex for various internal usage, like customer support. And they are starting to eat their own dog food by creating these agents and then putting them to use for inside internal projects. With that, let's move on to storage and catalog. Apache Iceberg comes in different specifications. It's a work in progress. Spec version 4 was announced only recently, but it's not finalized yet. Version 3 is a later spec, and now Snowflake supports version 3 spec. Just to talk about some of the things that are new in version 3 is Snowflake now supports not just copy and write, but also merge on read. Another interesting thing that Snowflake has done is right from its early days, it had support not just for a cloud native relational data model with separation of compute and store, but it also did a very good job of taking semi-structured data, documents, and storing it in a JSON data type called variant. That variant data type was then shared with the community, and it is now part of Iceberg v3. To give you some behind the scenes discussions I had, one question we had for Snowflake's management was that if Iceberg is becoming the de facto standard for as a table format, why have your own proprietary format? Why not just make it all Iceberg so everybody in the world can use Iceberg or Delta? I don't want to discredit Delta, although I'm publishing this podcast literally hours before Databricks Data and AI Summit 2025 starts, and we will be learning more about how Delta, Hoodie, and Iceberg are coming together. But for now, let's say Iceberg becomes the default standard. So our question to the product team was, why not just have one open format called Iceberg? Why even have proprietary? It turns out that Snowflake does obviously a lot of optimization. They have compression, they have encryption, they have replication. So there are a lot of features that are built into Snowflake's proprietary format, and hence they have their own. But the way they have donated variant, it is quite possible that over the years, that this differentiation between Snowflake's proprietary format and Iceberg may start to melt away. But that's just speculation. Let's get back to our announcements. The next one you see here says Polaris and Horizon. Polaris is a technical meta store. It is an Iceberg REST catalog. Horizon, on the other hand, is a business metadata catalog, like many other industry options that exist. And what Horizon does is it has a collection of not just data, but also AI models. And it is also well integrated with the marketplace. For example, if you create a data product, you can discover that data product read-only access through Horizon, because you're only discovering, you're not really updating it, and you can publish it on either an internal or an external marketplace. Several new announcements for marketplace, but just to complete this section, the Snowflake can now use Horizon catalog to read even external data sources, Oracle, Teradata, Power BI, all the ones that I mentioned that they are trying to extract data and migrate into Snowflake. Well, if you don't want to migrate it, but you still want to discover it in one single place, you can use Horizon Catalog. With Iceberg, it has bidirectional read and write support now with Iceberg. Any Iceberg REST catalog compatible catalog can be used. For example, AWS Glue or Dremio, and that is how this whole space is very, very rapidly developing. With that, I'm going to go to the last section. I'm calling it miscellaneous. There's, like I said, a long tail of new announcements here. The first one came as a big surprise, which is Snowflake is going passwordless. They have introduced a number of different security options, such as passkey, human-centric, using OAuth to connect to partner ecosystem, and several other announcements. But eventually, Snowflake's goal is to go passwordless. There were also several announcements for building transparency into cost, having that observability as to how the cost is trending, and then proactively trying to reduce cost, which also is a common theme in this conference. And one of them is cost-based anomaly detection. With that, we're going to stop here. Our next podcast will parse the Databricks Summit announcement. Also, I will be publishing a blog in which I will explain these different announcements. So with that, thank you very much for staying with me till the very end. Until next time, you've been an amazing audience. Bye-bye.